Wann haben Sie, meine Damen und Herren, sich zum ersten Mal so richtig verliebt? Hat damals der Blitz eingeschlagen oder wurde aus Freundschaft langsam Liebe? Wie auch immer es war, verlieben können wir uns offenbar ganz gut. Bloß, wie es mit der Liebe im Alltag weitergeht, das wissen wir nicht so genau. Mein heutiger Gast weiß es. Oder er hat zumindest dieses Buch hier geschrieben. Lauf der Liebe, das von einem Paar erzählt, dem es nach Irrungen und Wirrungen gelingt, die Liebe durch die Zeiten zu retten. Geschrieben hat es Alain de Botton. Seine philosophischen Bücher sind in vielen Sprachen Bestseller und seine Videoclips zu philosophischen Alltagsfragen begeistern Millionen. Mit ihm spreche ich heute über Philosophie und Liebe und darüber, was diese beiden Gläser hier mit der Zweierkiste zu tun haben. Herzlich willkommen.
Thank you so much.
Ja, Alain de Botton, Sie sagen, sich verlieben, das geht eigentlich noch ganz einfach. Warum brauchen wir denn Apps wie Tinder oder Partnervermittlungsagenturen?
Well, love is always complicated, and one of the big dangers is to think that love is simple or comes naturally. You know, it's amazing that we train in so many areas of life. How to fly a plane, how to run a business, how to make a surgical intervention. We train in everything. But when it comes to love, we just let people imagine that they already know how to do it. It's crazy. If I said I was going to fly an Airbus A380 to New York but had never trained, you would say this man is mad. But however, we let people, every generation, fall in love, start relationships, get into marriages without the slightest technical idea of what they're doing. Love is not an emotion. It is actually...
Well, okay. That would tie in with, what's his name's poem? Philip Larkin. Oh, sure. Man hands on misery to man. And how man hands on misery to man is that man fails to educate other people on love.
That's the one.
The very, very simplest of experiences, really, human experiences. The most fundamental and simplest of human experiences, and yet human beings do not teach other people about love. For some weird, strange reason. Well, I can understand why they don't, but you know, a lot of people don't get taught.
Yeah, but it's quite funny
So it goes along with what Alain was saying, and that is, people aren't trained in love. People aren't given the information or correct teachings about love to be able to enjoy love themselves.
Yeah, but it's when you go back to what she was saying, when she was saying about.
Let's just mute this.
Was it like a bolt of lightning? Just play it. Bolt of lightning. Or did a friendship gradually turn into love? However it happened, it seems we're very good at falling in love, but a lot of people say that we're very good at falling out of love.
Absolutely,
so,
of course.
Was it the right love to begin with?
Well, yeah, sure. But the thing is that when you listen to this conversation, the introduction, really, when you listen to it, you begin to realise that when this lady's talking about however it happened, it seems we're very good at falling in love. And then she asks or says, but what we don't know so well is what love actually is.
It's love itself.
It's love itself.
Yeah.
If you look up Wikipedia on love, you just get pages of romantic love. You get this quote that says that love cannot be consistently defined. So nobody knows what they're talking about. When somebody says, I love you, I mean, what do they mean? Somebody can love their car. I mean, would you like to be loved the same way as someone loves their car? I mean, come on. A human being is not a car. You know, so, I mean, I'd be very dubious if somebody said to me that they love me and yet they also said to me, but they love their car.
Yeah, but that might mean that they're actually mad.
To me, yeah, sure. And a lot of people do use words in a very manipulative manner. So we can't really trust people, you know, when they actually tell us that they love us.
And after all, Alain de Botton is only doing it to sell his book.
Absolutely. Well, Alain de Botton wants money. He wants your money to pay for his book, which means he can write more books. He can become more popular and get more money. And appear on more shows, be interviewed. Because apparently we live in a society where we kind of like suck up to all of these people who think they're experts. And yet, in a lot of areas, they're no more expert than what we are ourselves.
Then you or I.
Absolutely. Let's take, for example,
Come on, we should wrap this up and get on the move.
but let's take, for example, a radio show. And let's say you've got Brian Cox on your radio show, and you're having a phone in, okay, and people are ringing in asking questions about the natural world. Okay, now Brian Cox has only a story to tell about the natural world, doesn't he?
Yeah, story.
He's just got a story. And he knows, even though he knows things about the globe and the universe, all of this information, none of it can be proved to be true. So essentially, he knows as much about the universe or the night sky and the earth as much as what you do. So why do these people need to ring him up?
You can be very intelligent and very good at what you do, and you can still be stupid.
Yeah, well, we're back again. Annoying people with our views and opinions because
loads of people really dislike hearing other people's views and opinions.
yeah, a lot of people do dislike hearing other people's views and opinions because
Especially if your name is Professor Dave.
yeah, especially if your name is Professor Dave and you can't explain, or you tell him that he can't explain,
Oh, right.
and
yeah.
he realises himself that he can't explain.
It'd make a good Goldilocks, wouldn't he? If he dyed his hair.
Goldilocks.
Yeah.
Oh, absolutely. Yeah, sure. He reminds me of somebody out of like Ali Baba and the 40 Thieves. You know.
Mm.
Yeah. He just needs a tan,
Oh, right. Yeah.
bit of a tan. But,
Oh, right.
he's fine. But anyway, how are you, Peter? Are you well? Are you well? Or are you well?
I'm very well, thank you. And we hope you are all well too, albeit one or two of you.
Absolutely, of course. So, what have we got on for everyone's displeasure for tonight then, Peter?
Well, for everyone's displeasure. Did we mention that we saw 2 foxes today?
No,
Isn't that amazing? Saw 2 foxes.
2 foxes. Absolutely.
down
Yeah,
there.
yeah. They were such a wonderful,
Sight to see.
wonderful sight to see. Yeah, absolutely. Better than seeing 2 people arguing and fighting amongst themselves.
Right, yeah.
You know.
Can't be asked for that.
Absolutely, yeah. They were so peaceful, those foxes as well. They,
Yeah.
they were very calm when they were sitting around, just lazing around
Yeah.
the place. And then they went off on their own, on their way, didn't
And
they?
they were quite startled by their own reflections in the door.
In the door, patio door, yeah,
Isn't it
of course.
amazing?
But there you go. But isn't it amazing?
Anyway,
Isn't
come on.
nature wonderful?
Absolutely.
So what? Yeah, what have we got?
Right,
on?
okay, well, we've got, we're going to revisit the plasma channel, and we're going to revisit the atmospheric energy, because there was a point that we forgot to mention in our last video, so we're going to mention that. We're going to have a look at star trails again, because you've brought up something in conversation with one of our subscribers.
Oh, absolutely, of course, yeah.
So we're going to mention that. We're going to briefly talk about James May and him wasting his time.
Yeah.
We're going to have a look at electrical discharge machining, because it supports our view about water not being conductive.
Yeah.
And it also has implications for Nicholson and Carlisle.
Yes.
So we're going to have a look at that. We're going to have a look at Al Arandus gave us a link to a video on perlite. Some guy using perlite to grow plants.
Hydroponics.
So we're going to have a look at that. We're going to have a look at comets and dicarbon dissociation.
Yeah, it sounds complicated, but it's not.
Yeah, I know. We're going to have a look at that. We're going to got a video on our sodium metal in argon. We have the results in over about 3 weeks, I think.
3 weeks, yeah, we got
Look
that.
at that. Quickly look at salt and methanol, and we're going to have a look at this. Professor Dave can explain.
He thinks it's love, but he doesn't know what it is.
So he has to buy Alain de Botton's book.
So he has to buy Alain de Botton's book, and he can explain. Because he wants to explain.
Yeah, he wants to explain.
He wants to explain, but he can't explain at the moment. Absolutely, of course, yes. So big nose here. Absolutely. Has a lot to learn.
So the moral of the story is, whenever you don't know
Don't
something,
get advice from someone with a big nose.
always ask an expert. And as someone told me, an expert is someone who's an and just spurts out rubbish.
Absolutely, of course. Yeah, there have been. Yeah, has been. Yeah, sure. But isn't it surprising? Yeah, we mentioned about that. Human beings, they're all equal. They're all equal.
Yeah, we're all equal.
No one's better than anyone else.
Yeah.
Nobody can ever know anything about the natural world more than anybody else.
Yeah.
And a lot of the time, the people who think they know a lot about the natural world, none of it can actually be proved to be true.
Like how Professor Brian Cox, talks to people and tells people how the tides are caused by the moon's pull
Absolutely.
on the waters of the ocean.
Yeah, or how the sun is able to produce light and heat energy, for example, or how the nebula
nuclear fusion and fission.
Absolutely, yeah, sure. Or how a nebula or what white dwarf are created, or whatever, or black holes and all this kind of rubbish. And yet it's all a story, but none of it can be proved to be true.
No.
So it's all fantasy. So these kind of people, they know their stuff about their fantasy ideas, but with regard to the real world, they don't know. They haven't a clue.
Can explain.
They think it's real, but it certainly isn't. Because it can explain.
Anyway, come on.
So is that it then, Peter?
That's all, yeah. So let's get on and annoy a few people.
Excuse me, yeah, sure.
Come on, very quickly then.
Very quickly. Now, we're back on this video. We covered it last week, or in our previous upload. Drone harvesting invisible high voltage from the sky. Plasma channel. Now, the only reason why we're covering this again is because what we forgot to mention in our previous video about this video is that this is another example where somebody is putting forward some view of science, okay, which is the electrical gradient, the voltage gradient. Every meter up you go 100 volts. 2 meters, 200 volts, etc. Okay, so he's putting forward this scientific view about the natural world, that there's high voltage that you can harness from the sky, and yet what he's doing is that he goes up 115 meters. He should be able to get at least 10,000 volts from it. Okay, and yet all he shows to viewers is what he can do with an electroscope, which is this, and what he can do with a small ball of aluminium foil suspended between 2 cans of Budweiser. And that's it. And turning this, cylinder here.
All right.
10,000 volts minimum, and yet he's only able to do this. Now, that hasn't proved to him that the information that he's been given by science is bullshit, because he should be tapping into 10,000 volts here, but he's not.
Well, if I was doing this, I'd be thinking, hold on,
where's the 10,000 volts?
Where's the 10,000 volts?
But he doesn't do that, does he?
No.
So he's proving to himself that the science is wrong. Okay, he's proving that to himself, the science is wrong, and yet he still thinks that there is an atmospheric voltage gradient up there. Yeah, do you understand where we're coming from?
So I could tell he was even frightened to touch that wire.
Oh, there.
Look.
Yeah, he's a bit scared to touch it because in case he gets electrocuted with 10,000 volts.
But there isn't 10,000.
There's nothing of that up there. It's all bullshit.
All he's picking up are the radio frequencies and perhaps some microwaves in the environment he's in.
Absolutely, of course. So all this information by Electroboom, for example, and Richard Feynman, who introduced the concept of atmospheric electricity,
a voltage gradient,
is all bullshit as far as we're concerned, because nobody can actually demonstrate it.
Yeah, see, now, if he'd have connected his wire up to a multimeter,
absolutely, of course,
switched it on and the dial went up, or it read
10,000
volts, then we would accept that there is a voltage gradient.
Absolutely, of course. It makes sense really that when you look at this, there's his spool that connects to his cross antenna top with the frayed ends. Okay, this is the wire that comes down. Now, you would have thought he would connect this wire up to a multimeter.
Yeah.
And then when the drone is up there suspending his cross at 110 meters, he'd be recording over 10,000 volts.
Yeah.
But he doesn't do that.
Because that would verify that the voltage gradient exists at that altitude.
Absolutely, the voltage gradient is very real. But obviously, with a guy doing things like this is just rubbish, isn't it?
Yeah.
You know, but he hasn't clicked on that the science is bullshit. Yeah.
Yeah. It's very much
Because
like
he's not very clever, is he?
yeah. We can't think.
Absolutely.
It's very similar to Cody's lab.
Cody's lab
When he
did
had
exactly
his,
the same thing.
when he had his rocket charge on the end of an arm in his vacuum chamber, and he lit it,
And it spun round.
took the air out. Well, did it again, took the air out, and it didn't move.
Absolutely.
And like anyone would be thinking, because he did actually mention in that video, how is it they can get things working in space?
Oh, how right?
He did actually work. He did actually ask that.
Sure.
But what he did was that he enclosed the charge in a capsule of air.
Capsule. Yeah, sure. And which got it turning round.
Which got it turned around. But that's fudging it.
Yeah. So, and the thing with Cody did it again with his vacuum chamber when he had gunpowder in it.
Oh right, yeah.
He did it again. You know, couldn't even get gunpowder to ignite in a vacuum chamber. So he's doing all of these things that prove to him, that demonstrate to him through his own experiences, that a rocket will not work or propel a vehicle in the vacuum of space. He's doing all this stuff, and yet he still thinks that rockets work in space. Yeah. Do you understand how people are very psychotic? And this is what videos like this are showing to us, that people are deluded.
And it's exactly the same with
Action Lab.
Yeah.
Action Lab with his ion thruster. When he put it in a vacuum chamber, it stopped rotating.
After he took the air out.
After he took the air out, he reintroduced the air back into the chamber, and it started going again.
Yeah.
And then he asked himself, so why is NASA building an ion thruster to work in a vacuum in space when it doesn't work even in my vacuum chamber? And then he comes up with some...
maybe they've got to take the air up with them.
Absolutely. So he is doing things that demonstrate that the science is wrong. Okay, he's physically doing things with his own hands that tell him that the science is wrong, and yet
he wants to think that it's right.
But he wants to think it's right. This is it's madness.
Madness.
These people are psychotic. So, but if anyone's got any videos out there that are very similar to this, in that they show people doing things that demonstrate the science is wrong, and yet they still think the science is right, we'd love to see them. We'd love to send us a link, because we'd love to make up some kind of little compilation or something, wouldn't we?
Well, just highlight them.
Or just highlight them on our channel. That'd be very good, because, all they do is highlight how people are mad.
Yeah, in our opinion.
Our opinion, of course. That's something I'm very pleased that we've mentioned about that video.
Yeah, click that one off.
So I've clicked that one off. That's good. So the night sky.
Star Labs. Here we go.
Now, we got talking to Andreas Zhang and about the night sky and star trails and stuff. And one of the things we concluded through our demonstration, through our discussion, is that when you look at time-lapse photography of the stars, all of the stars move at the same rate across the sky. They're recorded. Everyone can see it. If you watch them, there's plenty of stuff material on YouTube. All the stars will move at the same rate.
And the moon as well.
And the moon. Now, if we accept the globe universe idea, okay, that stars are some of them are far away, some of them are near, they're at varying distances away from the Earth, they should all move at different rates. Yeah, some move fast, but some will move slowly.
Yep.
But we don't see that in a time-lapse video of the night sky.
Because with the globe model of the stars, it implies that there's depth to the universe.
There's depth, absolutely, of course.
Whereas this star lapse footage doesn't show. There's no indication of depth whatsoever.
Absolutely, yeah, sure. There's no indication of depth. Why is that stopped there? Oh, there we go.
Don't know.
Yeah, there's no indication of depth. No indication of depth whatsoever. If you look at the night sky or any time-lapse photography, you'll notice that there's no indication of depth. We cannot sense any depth to the night sky. Therefore, we cannot know or get an idea of the shape or form of the night sky, which is quite true.
Now, some people might say, "Oh, but what if? Some stars are brighter than others, so the brighter stars are closer."
Well, not necessarily. The brighter star could just be brighter than a dimmer star. That's all. But they could be the same distance away.
Well, it's a bit like saying how you can have a small person and a large person standing side by side,
Yeah.
and then someone could say, "But the large person is closer to you."
Oh, yeah. Somebody could say that. Yeah. But you don't know. You won't know because unless you go there,
Yeah,
unless you go and meet them, and
Yeah.
you find out, oh, hi,
yeah,
tall
basically.
person,
and you
oh,
shake
you're
both the hands.
Absolutely, of course, that's the only way. But nobody can go up to, in our view, nobody can go up and meet the stars, as it were. You know,
Oh right, yeah.
nobody can do it. You know, because you know, it's, people can
Unless you go to
pretend
Hollywood.
they've been there, of course.
Oh,
you
right,
know.
unless you want to go to Hollywood.
Yeah, you can get if you want to go to Hollywood or wherever.
Yeah.
You know, you can pretend. Man can pretend through the screen, the TV screen, or the video screen, or whatever computer
Yeah.
screen. He can pretend to go there, but as far as I'm concerned, they can't
Yeah.
go anywhere.
Yeah, you can wipe your feet on Cary Grant, can't you?
Absolutely, yeah, of course, yeah. If you wanted to, oh, that's a good idea, of course. But you know, I think the fact that when you look at the night sky, we can't get any sense of depth. That is basically in itself, that is a very good way that disproves the globe universe idea.
Right, okay. There we go. So thanks very much for that.
Absolutely, of course. So thanks ever so much, Andres Zhang, for that one.
There we go.
What's the next
Very
one? Let's
quickly,
click that off.
I'm going to now less Will James.
Will James, right, okay, yeah. Here we go. Will James be able to catch a lightning bolt?
Now, we were given this video because Al Arandus, I think it's him,
Al Arandus, yeah.
gave us the link to this video, and he asked, if water is a bad conductor of electricity, then what is the cause of lightning in clouds?
Is there an explanation? Yeah.
Now, in our
How
understanding,
about this? And that link will give us James May.
No, yeah. Now, in my understanding, lightning is caused through motion of the clouds,
Yeah, motion.
because all it is just a static discharge.
Yeah, okay, we'll go with that.
That's what I would say it is. It's just a static discharge, a build up from the movement. It's a bit like if you have
Voltage.
a bit like if you have a what's it called, that wheel.
Oh, yeah. I'm trying to think of the person who even thought invented
Or
it.
if a Tesla coil. No, not what's the other one? Not this. Got the ball on the top, and it has a belt going round
Oh, Van den Graaff generator.
like a Van den Graaff generator. It's moving. The
Motion.
belt is moving.
It's motion. That's how you
So-
get static,
That's basically.
through motion.
So it's just a release of a static electricity, static charge.
Yeah.
That's all it is.
So,
Well, that's it.
well, is that it? Oh, right, okay.
But the video with James May, this one, his Man Lab,
We won't play it because of copyright.
but all it is that he sends up a rocket into what he thought was a thunderstorm, attaches a wire to the rocket, and he's hoping, him and his team are hoping, that a lightning bolt will be attracted to the wire and then come down
Well, be conducted down through the wire.
through to the ground.
Through to ground, and then there you go, you know. But it doesn't
didn't
happen.
work. Didn't work.
Well, he didn't even get any lightning.
Yeah, I know.
I don't know why he fired his rocket. I mean, a waste of time, really. Waste of time, waste of money, and it makes piss poor viewing as well.
Yeah, I know.
But all these people, follow James May, and think he's God or think he's whatever,
I know, yeah.
It's just rubbish.
People like him would do anything for TV.
I'm
for
sure they
viewing.
would. Yeah, that's the trouble. That's the trouble with all these stars, even YouTube celebs as well, if you want to use the word. Even they pump out videos just to keep their audiences sweet.
I remember the one where
Even if it's rubbish, they'll still pump it out.
I remember the one where they were building a bridge in Liverpool.
Oh, I know. Yeah,
They were building a makeshift- a footbridge out of Meccano, wasn't it?
yeah, Meccano.
You know, and I'm thinking, you know,
It's just ridiculous. It's ridiculous. Yeah, and the cost of all these TV programs is phenomenal.
It's crazy, yeah.
Crazy. They got to pay for the location. They got to pay for all the crew, the staff,
Meccano.
the canteen, the food,
Yeah.
the drinks,
Yeah.
all of the equipment.
Yeah,
They've got to have all of the equipment they use to show. They've got to pay for that to be made. The rocket to be made, launched. They got to pay for all that. It all comes out of the funds for the TV program. It's just a waste of money.
Anyway, come on.
Total waste of money.
See you, James.
So does that answer?
Yeah, it does.
Our
Water is a bad
horrendous,
conductor of electricity. Then what is the cause of lightning?
lightning. Yeah, it's just
motion of the clouds.
Yeah, you just get a static.
Because in our view, see, we don't know. That's our opinion. In our view, the clouds are made of salt.
Yeah, absolutely. Yeah, sure.
How that salt interacts
And the
with
salt is hygroscopic, which will attract moisture in the air.
And when you've got more salt attached to, when you've got more water attached to a salt,
Yeah,
I've forgotten what the word is.
yeah. It gets so heavy that the water
falls
the
off.
water falls. Yeah, which makes kind of sense. But because all of the particles, the salt particles, aren't joined together, this is why you get your sheet lightning, because you get sparks between each single one.
Yeah, because you'll always get a spark when there's nothing to conduct.
When if you got a spark plug, for example, you'll always get a spark because of the electrodes. There's nothing between the electrodes for the electricity to be conducted. So the air between it wouldn't conduct the electricity. So you get a spark. Now, if you bridged the gap with a wire, you wouldn't get a spark. So if you've got conductance, you won't see a spark. You'll only see a spark where electricity
There's no conductance.
Where there's no conductance, which makes sense. So when you see a lightning bolt from cloud to ground, when you see cloud to ground lighting, the only reason why you see the bolt of lightning is simply because there's no conductance between the cloud and the ground.
Yeah.
It's simple.
Okay.
The same with sheet lightning up in the top in the clouds. The reason why we see the lightning is because even within the cloud there is no conductance. So that makes total sense, doesn't it?
Absolutely. See you, James.
So bye, James. So thanks, Arandus, for that one.
Here we go.
So we'll click that one off.
Discharge machining.
Electrical zero tolerance. Now this one. Execrate gave us this one. Now zero tolerance machining. We don't need to know much about the processing of electrical discharge machining, because all we're looking at this for. The reason why we're looking at this is simply what the narrator states in the video, which supports our view on water, isn't it?
Yeah, basically. Yeah.
So we'll just jump to the part of the video where we get where we need to be looking at. I think we can just watch it from here, can't we? Really? Yeah. Right. Okay. So let's just listen to this very carefully. Okay. Are you ready?
The EDM wire. The coolant is deionized water. A brass electrode burns 4 holes for the 4 puzzle pieces and 2 as backup. Next, we program the machine. Then we load the steel block into the EDM. We mostly use brass wire that's 10,000ths of an inch thick. That's about 3 times the size of a human hair. For some projects, we use a wire that's 4,000ths of an inch thick. The typical tolerance for a project like this is 1/10 of a thousandth of an inch. We fill the tank with deionized water so the liquid has 0 electrical current. The water is safe to touch, which is why we can put our camera lens underwater. After threading the wire, it creates an electrical arc that burns away any conductive material. The water flushes the material waste away, and the water is recycled. Despite this, the water gets very dirty within 5 minutes or so we can't see much after that point. After one piece comes out, we rethread the wire to cut the next piece, and so on. After about 2 hours of machining,
That's all we need to listen to, really. Yeah, I mean, when you think about it, the guy is basically asserting our views in that water doesn't conduct electricity.
Yeah.
Because if it certainly did, then
They wouldn't be able to
the
do this.
the electrical discharge through the wire, they wouldn't be able to do this, would it? Because they'd lose the voltage. The voltage would go. So they need something that is a non-conductor of electricity in order to be able to separate the wire from the actual material. The water will surround the wire from the material.
And this also ties in.
So to enable a spark.
Yeah.
To create the spark.
And this also ties in.
Which ties in with the clouds.
Absolutely. And also ties in with Nicholson and Carlisle way back in 1800, because when they performed the electrolysis of water, if they'd have used distilled water, they would not have had any conductivity using their voltaic pile between their platinum wires. They wouldn't have had any conductivity at all. So they must have used an electrolyte.
Yeah.
They must have. So the electricity isn't breaking down the water. It can't break down the water.
Yeah,
So
absolutely.
it has to be breaking down the electrolyte and or
The
the
electrodes.
electrodes or decomposing them.
Absolutely, yeah. You know, I mean, there's so much information on our channel that supports our view that water is not H2O and it doesn't conduct electricity. I'm surprised people actually still think that water is H2O.
Yeah, I know, yeah.
You know, it's madness, isn't it, really, when you think about it?
But again, it's one of those examples where you're showing to people, or people are here, they can watch this.
Yeah,
people on Professor Dave's channel.
Oh, okay.
Who we're chatting with, they can watch this video, and it's clear that water doesn't conduct electricity.
Absolutely, yeah. And what about all the heat that's produced with the amount of voltage?
Yeah.
It's enough to cut through metal, okay? Yeah. And yet, do you not think that some of the water, in their eyes, would split into hydrogen and oxygen? Well, of course it doesn't.
Yeah.
It's because
it doesn't.
It doesn't. That's why.
Come on,
you know. But I mean, thanks ever so much, Execrate, for that. I mean, it's a good catch because it just basically supports our view regarding water and its non-conductivity.
There we go. Still another one.
So thanks ever so much for that.
Here we go.
Now, I'm trying to think who gave us the link to this one. Was it?
I'm not sure. Yeah, Alarandus.
Alarandus. Yeah, here we go. Two more things in the name. Next, check the link. He never do plants ventilation for a month. No oxygen needed. Now, the link that we get from that one takes us on to what was it? Lies people tell. Not that one. Not that one.
Well, you can. Magical properties.
Oh, sorry, this one. Yeah,
this one.
The magical propagation method. 100% success rate. John Dennery. There we go. I've been using this method for several months now and have had 100% of cuttings grow healthy roots. Magic. It's not magic, really, is it? But what the guy basically it's all about hydroponics, and hydroponics is growing cuttings without soil, or growing plants without soil. So in the tub that he's got underneath his light there, he's got some jars, and in the jars is they're filled with perlite, and he's got cuttings. He places cuttings in, and he just leaves them under the light, and he gets 100% success rate.
Absolutely.
I mean, pretty good. Now, a lot of people might be thinking, "Well, that's amazing."
Marvellous, isn't it?
But I mean, it's all right. So we got perlite here on the Wikipedia page, just to give us some information, general information about it. And perlite is an amorphous volcanic glass.
Amorphous meaning?
Amorphous, something to do with water, I think, in condensed matter physics and material science. And amorphous or non-crystalline solid is a solid that lacks the long-range order, which is a characteristic of a crystal. Well, it's a crystalline structure.
Right, okay.
A crystalline volcanic glass, that's all, that has a relatively high water content. Well, there you go. And I wonder why, when we look at this, he's obviously not watering his plants because he doesn't need to.
Because they've got water in the perlite.
Because there's water in the perlite. So, you know, when he holds up his little jar there filled with perlite there's plenty of water already in the jar.
Yeah.
You know, so, you know, he doesn't need to water them at all. And here we go, perlite. It occurs naturally and has the unusual property of greatly expanding when heated sufficiently. It is an industrial mineral suitable as ceramic flux to lower the sintering temperature, and a commercial product useful for its low density after processing. So,
But another thing that's interesting with it is that it contains a lot of oxides.
it contains a lot of oxygen. Typical analysis would give you silicon dioxide 70 to 75%,
Aluminium
aluminium
oxide,
oxide, sodium oxide, potassium oxide, iron oxide, magnesium oxide, calcium oxide. You've got all of these, well, all of this stuff that contains oxygen. It's because it's volcanic. It's come from areas near volcanoes.
Heat.
Where the rock's been heated, where it's been molten, and it's probably flowed down the side.
Yeah.
And it's basically calogenated in its molten state, cooled and trapped in the air. That's been absorbed through when it was hot, and obviously being oxygenated. So that's our understanding of this kind of stuff. But we wouldn't call it magical propagation at all.
Well, not really.
But we can understand why
they grow.
Why they grow. I mean,
Because one thing you got to remember is that when he's put the lid on and put it under the light,
Yeah,
the
yeah.
water will evaporate from the perlite
perlite, yeah, and just be absorbed in the plants.
and be absorbed in the plants.
Yeah,
But you've got a kind of cycle, haven't you?
because the plants will release that moisture.
because you also have the oxygen will be released from the perlite
Absolutely,
over
yeah,
time
sure.
as well.
So it's it reminds me of the guy who had his terrarium.
They may as well have. They could have incubators with babies in there
Yeah,
to do the same job.
yeah. I wouldn't. Right. Yeah, it's possible. Yeah,
It would.
Yeah, yeah, sure. Well, you could even have. I suppose you could even have submarines on there, and you've got lots of perlite.
Yeah.
You've got lots of perlite. The perlite will absorb a lot of the waste air, wouldn't
Yeah.
it?
Yeah.
And it would probably regenerate,
Yeah.
perhaps.
Yeah.
Well, I mean, if plants can grow in just perlite, what's wrong with humans living
Yeah, I
in an
know.
environment?
The oil globies can take perlite up to space, can't
Oh,
you?
absolutely, yeah. You can have perlite, NASA, and they've their new technology, their new perlite technology
Oh, right. Yeah.
for breathing.
Yeah, breathing, yeah.
Yeah, you can have space. The space astronauts can
Perlite
when they
pumps.
land on the moon, they can have a perlite canister.
Oh, right. Yeah, I like that one. Yeah.
You know, they can do all this, but it basically goes to show that plants basically will grow in many places,
Well,
and they don't need an awful lot of stuff.
Well, you can even grow plants in a gutter.
Makes you wonder, really, why farmers put all these fertilizers in the ground.
Yeah, I know.
You know, I mean, I don't know. I mean, I haven't a clue.
because
why.
they're told that the fertilizers will make their crops grow better.
Absolutely, and they're making all of this stuff to make money.
Absolutely.
They're making all of these phosphates and
nitrates.
and all of this other stuff
Yeah.
to make money.
Yeah. Big money, that is.
As it to make money, so they're making them, selling them to farmers for when they don't need them, and they're bunging them on the soil because they want to. They're thinking that they've spent the money, so they want a return on their money. So
Yeah,
that's why they do it.
Anyway,
It's ridiculous. But anyway,
so there you go. Thanks
so
very much.
nothing.
For that.
Very good perlite. I mean, seems quite a good
No,
stuff.
but you could probably use it as a. You could probably use
One
it
thing
as
that's
a,
interesting when you look at his tub at the moment, can you see all the condensation on the side of the?
Yeah, I know. Yeah.
You can see all the
That's after
condensation.
he's taken off the
The
lid,
lid,
because
yeah.
it shows how much moisture is released from that perlite.
Absolutely, I'm surprised you can't see moisture on the side of that jar that he's holding up. Bit of condensation or something. You can see it on the side of that tub.
Yeah, I know, yeah.
But
Yeah, but it would leave. It would actually leave that, wouldn't it?
yeah, absolutely, yeah, sure. So anyway, that's wonderful stuff. I mean, I'm not into plants at all, really, but not my thing, really, growing plants. Anyway, thanks ever so much for that.
There you go, done that one. Comets and dicarbon dissociation.
Well, now this is one we had a little look at, didn't we?
Yeah.
Chemistry world, absolutely. Now, Comet's green colour comes from dicarbon dissociation. Experiments confirm. Amazing. Now, isn't it amazing how an experiment that they've carried out confirms that a comet's green colour comes from dicarbon dissociation?
Isn't that amazing?
Isn't that amazing? How on earth did they confirm that? I really don't know.
Yeah. All experiments confirm that a dicarbon dissociation causes a comet's green colour.
Yeah, I mean, it's amazing.
And they haven't even been to space.
They've not even managed to catch a comet.
Yeah.
Or even catch a falling star and put it in your pocket.
Yeah, to even
You
know
know.
what it is.
Absolutely. So we've got a picture of Comet Lovejoy here for some reason. But you can see the blue, the turquoisey haze around the white core, which I believe is the coma, I believe.
Yeah.
And you got the tail out the back. Now,
Which looks
we
blue
don't
to me.
need to go anything.
The coma's green glow comes from diatomic carbon, a simple yet unstable form of elementary carbon.
Yeah.
Science, but you show us a form of elementary carbon.
Yeah, somebody please show
Somebody
us.
please show us a form of elementary
Carbon.
carbon.
Yeah, people will show you an isotope of carbon, like
Graphite.
charcoal,
Diamond.
Well, that's if diamond is.
Oh, because in our view, a diamond is a salt.
Is a salt, absolutely, of course. But nobody can really show you a piece of elementary carbon.
Yeah.
Nevertheless,
Scientists have suggested that as dicarbon streams out of the comet core, it is destroyed by sunlight.
well, there you go.
Aren't most stars during the
Well, all
daytime?
stars are destroyed by sunlight, aren't they, really?
This is why the comet tail, unlike the coma, is colourless. Well, according to that photo, it looks blue to me.
Yeah, but this is a picture of Comet Lovejoy.
Sorry, it's colourless in sunlight.
It's colourless. Oh, okay.
Sunlight.
Sunlight, yeah. Comet Lovejoy.
Anyway, so, however, the precise mechanism of this supposed photo dissociation had remained unclear.
Until, dum-dum-dum,
Researchers in Australia and the US have now for the first time observed diatomic carbon's photo dissociation
in the lab. So here we go. Now, here we go. We've got another example of where someone's carrying out something in the lab or in their workshop or at home on the kitchen table and then applying their findings to the natural world.
That's right.
Another example.
That's right.
So the team produced dicarbon by photolysing tetrachloroethylene and then breaking it apart with laser pulses. So basically what they've done, I think, is that they've carried out this photolysing of tetrachloroethylene, with breaking it apart with laser pulses and got the glow that looks very similar to the comet in the photograph.
Yeah, basically. But you've got to remember that the laser would have a colour to it.
Absolutely, of course. Yeah, well, the lasers, absolutely. The laser is part of the procedure in the lab.
Because they're making it up.
They're making it up.
Yeah.
But because they've found a similarity in the colour, they've gone, this is what's happening up there to the comet. Yeah?
That's the one.
And this is how man creates his
Reality.
story about the natural world. Because that's all you get from Brian Cox and David Attenborough about animals and all these other people, all these other people,
Neil
education,
deGrasse,
Neil deGrasse
Bill
Tyson,
Nye.
Bill Nye, all of these people have just got a story about the natural world, and yet none of it can be proved to be true. None of it. It's all an idea. It's just a story, and the story starts in the lab.
That's where it all happens.
That's where it all happens, because they do things in the lab, and then they extend or apply those results or those findings to the natural world.
Just like the
Blue Marble Science with his Cavendish experiment.
Oh, right, yeah.
And his torsion balance.
Just like the molten iron core of the globe Earth.
Yeah. Or the solid. I don't know if it's solid or
No,
molten.
it's molten.
Or molten.
How did the molten iron get down there to begin with?
To the core of the Earth.
But then again, what was there before it?
Absolutely. Well, scientists have carried out a study in the lab where they basically forced molten iron between silicate plates. And because they could do that in the lab, they say that that's what happened to get the iron in the core of the Earth.
Wow, isn't that clever?
Isn't that clever? Do you not think that man is just creating their kind of story about their information about the globe and all this?
Yeah.
They're creating it because that's the only way they can have all this information,
Yeah, there we
because
go.
they've created it.
There you
all.
are then. We've
But
done
anyway,
that then.
so
Now we've done though.
yeah, absolutely, of course. But this is at the point we're trying to make about this one, isn't it?
Yeah, we've done it.
But it's just created. It's just so really what it should be. The headline here should read: Comet's green colour comes from dicarbon dissociation.
No, does.
Yeah, could. Comet's green colour come from dicarbon dissociation. Experiments confirm the hypothesis that it does.
Yeah.
all the experiments do are confirm a hypothesis about the comet's green colour, but they've still yet to prove the hypothesis.
Yeah.
And this is something that runs through a lot of science, and that is a lot of the scientific claims presented to you, me, and everyone else in education and everywhere else is just ideas. They've yet to be tested to be true, or they've yet to be proven.
Yeah.
Water H2O is another hypothesis that's yet to be proved. The globe Earth is a hypothesis that's yet to be proved. Anyway. And that's it, isn't it? So that's it, yeah. So we don't need to look at electrical discharge machining, do we?
No, we've done that.
We've done that. So I thought I'd get the page up there. So we've got the perlite there. We don't need that. So we've done that one. So
Argon and sodium metal.
argon and sodium metal. Now let's get back
Very quickly.
very quickly.
Just check the time, can you?
I'm not. But no, I think we should just carry on. Now we actually managed to take our sodium metal out of the argon jar. If people can remember, some time ago we put we had our glove box
16th of December.
filled with argon.
I think it was.
Okay.
16th of December.
We got our glove box filled with argon, and we cut some sodium metal and we popped it inside a jar filled with argon. Okay, all in our glove box, and we closed the jar. And this was on the 16th of December last year. There are the two pieces of sodium metal. Okay, and we took another photo on the 29th of December, which is this one here. And the other day we actually opened up the jar. And this is the video. So let's just show everyone the video. Okay, so here we go. Let's just, oh, there we go. So let's just, so there are our pieces of, this was on the 9th of the 1st, 2022. 9th, so that was the other day, wasn't it?
Yesterday.
So there are our pieces of sodium
Oh, one
metal.
looks very white indeed.
One
doesn't
looks, they have gone whiter,
Yeah.
haven't they? Nobody can dispute that.
it? Yeah, the one on the right does look a bit yellowy because that's the
Mineral
side
oil
that was exposed to mineral oil.
Yeah, but as when you hold the if you hold it up, you'll be able, and when you turn the jar, wait there, you turn it, you'll be able to see how white these pieces actually are. They are very white indeed. They're like sugar, aren't they? You know, you can clearly see the one at the back is like a sugar cube, and even the one at the front is, there you go. They're looking very white indeed. They have obviously changed since they've been in this jar.
Yeah, see now a lot of people, again, for those who aren't aware, a lot of people say that in order for that sodium to have gone like that, it would have to have reacted with oxygen.
Absolutely, of course, but because argon's an inert gas, and we've been told, or I've been told, that argon, the sodium metal, should have maintained its metallic lustre. It shouldn't have changed into whitish, whitish substance at all. In argon, it should have just remained unchanged because argon is inert. But obviously something's wrong. It does change,
Well, you'll have to...
Yeah, no, yeah, it does actually change. Argon, or the sodium metal does change in argon. So it could be that the sodium is reacting with the argon,
or it could be that the sodium metal just decomposes, whatever the case.
whatever the case. So the only way we can find out is to see whether there's argon still remaining in the jar.
Because think about this: if you made a
So
piece,
that was the date we did it.
If you made a piece of sodium metal and placed it in mineral oil, which is supposed to protect it from water, because water is the very thing that actually decomposes it.
Well, it will preserve it.
It will preserve it. It should be metallic, but it doesn't.
It doesn't.
Because the mineral oil does actually react with the sodium metal, and it goes yellow on the surface.
Yeah, it's crusty yellow.
Yeah.
Coating.
So it does have a desire to decompose.
Sure. So let's have a little look. Now we've done this before, and we've had sodium metal. We've filled up a jar with argon, popped in some sodium metal, closed, sealed it up, and then a couple of weeks later we opened up the jar and the argon had gone. Argon puts out a flame, extinguishes a flame. Whereas what we did before was that we put in a lit splint and the splint didn't go out. So the argon had disappeared. So is it going to do the same again? So let's have a little watch of
Or
this.
it had reacted with the
Or
sodium.
it could well have reacted with the sodium. So let's have a little look at this. This has been 3 weeks. Roughly 3 weeks. Let's see if there's argon still in the jar. Here we go. Will it go out? No. Hasn't gone out at all, which means there is no argon that's detectable in that jar.
Gone.
It's gone. Another example or another time where, you know, the argon's gone.
Yeah.
You know, if argon's supposed to be an element, okay, an inert, doesn't react with anything, where was the argon? Where's it gone? Something's seriously wrong with the information about argon.
Yeah.
Absolutely. But there are our two pieces of sodium metal. They're looking very white indeed.
In that argon has a very short shelf life.
Yeah, it's possible. But so what we're going to do is that we do intend to put some argon in a jar and just leave it for a couple of weeks.
Same length of time.
Same length of time, and see if it survives, basically.
Yeah.
So that's our next
14.
Our next job we've got to do. And
24. Just over 3 weeks that was.
Just over 3 weeks.
24 days.
Do we need to show about the methanol and the...
Yeah, we can just quickly show that we just want to show this for demonstration purposes in that salt does not dissolve in methanol.
Absolutely, yeah. We've got some methanol, poured some methanol in the jar, and we're connecting up our electrodes. Wait there, let's go through. We're faffing about here, trying to get our electrodes together in the right position. There we go. We've got them there. We've got it there. We're adding some, there's our salt.
There we go.
We're adding some salt there. Sodium chloride, British table salt. British. That's a joke, isn't it? There we go. We're sprinkling in some salt there. And I mean, we've got how many volts? 30 volts through this.
Yeah.
I mean, we don't have a current as such because methanol doesn't conduct electricity, and salt added to it doesn't do anything.
Yeah, and the reason why we consider this not having anything is because the water is saturated with methane gas.
Yeah, absolutely. Yeah.
So there's no free water
to dissolve
the salt.
Absolutely. So the salt isn't able to dissolve in the methanol.
Yeah.
Yeah, that makes common sense, doesn't it?
Yeah.
So unfortunately, you know, it seems to be a dead end using methanol.
Yeah, but we only did that just for demonstrative
purposes only. Of course. So thanks ever so much for that. That's that. Yeah, we had 16.9 volts we had on that, but we still didn't get any bubbles. No motion or anything.
Nothing. There you go.
Absolutely, of course. So thanks ever so much for that. And I believe we're
on our
last one. Yes, it's Professor Dave Can't Explain. Absolutely, of course.
Can explain.
Can explain. He thinks it's love,
but he needs to buy Alan Butter's book so that he can know that it's true.
Oh, can explain. Now we were on.
We
found a video.
Oh, this is a great video
called "Lies People Tell About Water." Yes. It was uploaded by Professor Dave Explains.
Yes, you've got it. You've got the very thing that crossed our minds when we saw this video, and when he's doing a video about lies people tell about water.
Yeah, so we had to leave a comment. Oh, we don't want to play that, or we don't even want to watch that. No. So we left a comment here. Let's just maximise it for everyone's pleasure, or displeasure, I should say.
Yeah. Great video, Dave.
Great video, Dave. Can you take a look at another lie about water? People are saying that water is made of hydrogen and oxygen. A great place to start is Nicholson and Carlisle, who, in 1800, performed the very first electrolysis. I'd love to know how they concluded water is split into hydrogen and oxygen after performing their demo, because I think the gas products came from the platinum wire used as electrodes and not the water. Any help would be great.
Yeah.
So we've had 8 replies, not many, but even Professor Dave replied to us, didn't he?
Oh, well, he's got 3 thumbs up for that.
Yeah. He writes, electrolysis splits water up into hydrogen and oxygen gas, H2O. Right, okay. And we had a little chat with Dog Walker as well. He interrupted into the conversation, but we don't need to discuss Dog Walker.
Well, we've chatted with him before in the past.
Sure. But so we replied to Professor Dave Explains. Yeah, thanks for explaining to me how electrolysis works. But that's the lie.
Right, yeah.
Electrolysis is not a proof that water is split into hydrogen and oxygen. Nicholson and Carlisle in 1800, the discoverers of electrolysis of water procedure, somehow determined water is split into hydrogen and oxygen, but the gas products could have originated from the metal electrodes. Yeah? Nicholson and Carlisle never carried out any further investigations to prove they were right. Any ideas, Dave, on how they knew? Because we'd like to know how they knew.
Yeah.
Plus
Plus
the
the water they used had to have contained impurities that would have conducted the electricity from the voltaic pile. And so the H&O could have originated from the electrolyte as well. Very similar to the electrical discharge machining when they used distilled water.
It doesn't
conduct electricity. So in order for them, Nicholson and Carlisle, to get a conduction between the two platinum wires, they would have had to have used an electrolyte.
Absolutely, yeah. Or they would have had to have used water that would have contained impurities that would have conducted
electricity.
They couldn't have used clean water.
Yeah.
Very clean water, like distilled water.
Which supports our view in that you're not breaking down the water.
Absolutely, of course. So we won't talk about dog walker at all. We won't get involved in that conversation. But we got Professor Dave explains. He explained by saying, "Petey, you're dumber than rocks." Okay. Visit my chemistry tutorials when you get tired of having no clue what you're talking about. And you think, this guy is absolutely a jerk, isn't he?
Yeah, I know.
When you really do think about it, because he's not realising.
He can't engage in a discussion.
Absolutely, because he knows that what you're talking about is a very good question. It's a very sensible question, but it's a question he can't answer. He knows that. So we replied to him. And we replied to him and to Dog Walker as well. Hurtling abuse at people is a typical response from somebody who is deluded, and it reveals how unreasonable you are as a person. I asked you a very simple question regarding the electrolysis of water performed by Nicholson and Carlisle over 200 years ago, a subject you should be familiar with, because I believe this guy has taught chemistry. I believe.
Understand.
And considering your YouTube credentials of being a professor who explains things, you strangely can't seem to provide an answer. Maybe you should rename your channel to Professor Dave Can't Explain, or doesn't want to explain. Again, how did Nicholson and Carlisle in 1800, the discoverers of the electrolysis of water, know the gas products, being hydrogen and oxygen, originated from the water being split and not from the materials placed in the water, that is the electrodes and or the electrolyte? Yeah, simple question, but can you answer it? I'd love to know how they knew. In my opinion, they could never have known the true origin of the gases, with numerous variables present. Bear in mind, 3 variables present: the electrodes, the electrolyte and the water. How could they have known that the gas products come from the water solely when there were other variables present, and they didn't do any further tests to remove or isolate or identify that the other 2 variables, the electrodes and the electrolyte, didn't take part in the electrolysis procedure at all? So that would leave the water. What did they didn't do anything.
And for your information as well, as dog walkers, we know how submariners breathe in subs for long periods. They use chlorate candles
to produce oxygen,
and they use a scrubber to recycle exhaled breath. They keep the air in constant motion, because that's the key in keeping the air fresh. It's always keeping it moving. They also use electrolysis to produce oxygen, but the gas, in my opinion, originates from anodic decomposition of the electrode and the breakdown of the electrolyte, e.g. potassium hydroxide, K, O for oxygen, and H.
And the H would be discarded overboard, wouldn't it?
The hydrogen.
Just discharged overboard.
In my opinion, oxygen does not originate from the water.
Yeah, and then after that comment, that's been it. So, we've not heard anything from them
A
at
dicky
all.
bird.
7 days ago, and that's it. It just goes to show that Professor Dave can't explain at all. He can't explain something that's very, very simple about water. It's because his understanding of water is totally wrong. He can't explain because it's wrong.
Yeah, basically.
He can't prove water is hydrogen and oxygen at all.
And he can't use his imagination to come up with some kind of explanation that would disprove us.
Absolutely. Well, nobody can.
Discount our view.
Absolutely. Nobody can. Nobody can do that. For some reason, I really can't understand with the amount. Well, I can understand, but the amount of information that's on our channel in numerous videos, as far as I'm concerned, is enough to convince any reasonable person, okay, that isn't psychotic, that water is not H2O.
Yeah.
There's enough information already for any reasonable and rational person. It just goes to show that people like Professor Dave, who can't explain, is an irrational, unreasonable and psychotic individual who basically goes through life in a deluded state.
Yeah. In your opinion, of course.
In my opinion, of course. Yeah, that's my opinion. But if you was to ever meet him, you'd probably agree with me. Absolutely, of course.
Well, yeah, basically.
So
whatever you do, don't talk to him about love.
Absolutely, because he can't explain. Absolutely, of course. So
that's it.
There we go. We've done that quite well tonight, which is very good. So there we have it. We've done superb. So let us know what you think. Leave us a comment below.
Yep.
I mean, if you've got a video that you'd like us to look at or any information that supports our views and opinions that you think we'd be interested in, just let us know. Leave us a link. It probably would get held for review, but we'll find it. So, and let us know if you find any other videos where people are doing things that prove their science wrong, but these people still think their science is right. Yeah, absolutely. Because it just goes to show that a lot of these people are
mad,
being psychotic, mad being deluded.
Yeah. Well, I mean, it's going back to that plasma channel. If he linked it up to a multimeter, his wire from his antenna,
a voltmeter,
a digital multimeter, and it read on there 10,000 volts. But if he dropped his drone, you saw the
figure going
down. You would then accept that there is a voltage gradient in the atmosphere.
Or you'd be more convinced.
Yeah. But because you don't see it,
absolutely,
you can't accept that there is.
But the guy thinks there still is, even though he's done a whole video about it,
and even though he's only managing to turn a little
piddly wheel, drum. Absolutely, that's just made out of lightweight stuff.
Oh, I was thinking about Wimshurst machine. That's the Wimshurst. See, Wimshurst machine, you have to turn it to create motion.
To create static. Absolutely, because
it's all about motion.
Absolutely, motion. Absolutely, and absolutely, of course. So there you have it. Yeah, I mean, it's wonderful stuff. And so hopefully the next thing we do will be showing argon in a jar. And let's see if argon will survive 2 weeks in a glass jar on its own.
Yeah, and we've also got to do the sodium metal in CO2.
Well, sodium metal in CO2, which we think will still go white, still degrade. Absolutely, of course. So there we have it. We've got lots to do this year, which is wonderful. Get off to a good start. So thanks ever so much. And always remember till next time, if something doesn't make sense, like
oxygen being 21% of the air.
Or even thinking that there is an atmospheric electrical voltage gradient in the atmosphere that goes every metre up you go, it increases 100 volts.
Yeah, or thinking that perlite doesn't contain any water.
Absolutely, of course, or oxygen as well.
Because
think of it.
Because perlite, if you heated it up so the water evaporated, then you would have it would act like a desiccant.
Yeah,
well, it would just absorb. Hygroscopic. It would just absorb water because it's so dry.
Absolutely, yeah, and yeah, of course. And if you got, I suppose that's quite true. Yeah,
if you think the Earth has magnetic poles,
absolutely. If you think there's an iron core, molten iron core in the centre of the Earth, If you think that water is H2O, if you think the air has constituents of oxygen, nitrogen, argon, small traces of CO2, naturally occurring.
Yeah. Oh, we do have to do that video about the atmosphere and gases.
Oh yeah, we should do a recap
We'll do that
on the
next time. That'll be our next video.
On the our next video should be something about the atmospheric air constituents.
Yeah.
Just to help our new subscribers to understand the concept.
Yeah.
Of
If you think
what
white
our
light,
ideas.
white light is made up of red, blue, and green.
Absolutely. If you think fish breathe dissolved oxygen, absolutely, of
If you
course.
think we breathe in oxygen and through the process of cellular respiration, we exhale carbon dioxide.
Absolutely, of course. Yeah.
2 parts oxygen, 1 part carbon.
Yeah. Or if you think plants give off absorb CO2 and release oxygen in the natural environment.
Yeah.
Of course. If you think that the carbon cycle is real, the nitrogen cycle is real.
Yeah.
If you thought that radioactive carbon-14 is naturally occurring. If you think the sun's light is electromagnetic.
Oh, right, yeah. Because all you're really learning about is how man is literally fucking around
With his environment. And creating this illusion
Yeah.
that he knows everything about the natural world.
Yeah.
When he doesn't know anything about
Yeah.
it. Yeah, that's basically what it boils down to, yeah.
Right.
It's ridiculous, isn't it? Yeah.
Well,
it's all rubbish, isn't
yeah.
it? It's all a load of rubbish.
Okay.
So thanks ever so much, Dan. We'll see you next time.
Okay.
Bye.
Ta-da.
The Earth isn't round, it's flat. How do you know? I've observed it in all my travels over Europe. It's flat. Everywhere it's flat.